Welcome, everybody. I know a few people are going to be struggling in. Thank you, everyone, for coming on this last Thursday of February. So we're going to get started in just a moment. I'm going to do my normal announcements, then we'll go into the talk. First thing we always do when this was in person, we would ask who is hiring. Now, unfortunately, we can't have just someone stand up and say, hey, I'm hiring anymore because, we're on a screen. So if you have a job and you're looking to hire people, go to the Slack. We have a Slack, and the best way to get to that is nyhackr.org/slack.html. And there's a link there to join our Slack team. And once you're in the nyhackr Slack, which is just nyhackr.slack.com, assuming Slack isn't down, you can go to the job postings channel. It's job-postings, and you can post your job there. I'm just going to scroll really quickly here. I see a job open up here for openlifesci.org. I see the Council of State Governments is hiring. I see it looks like our OpenSci is hiring. And that's just a few that I can scroll up to. Blue Rose Research, our studio, all sorts of good jobs posted there. So if you're looking for a job, go to the job postings channel and find a job. So it's we bring people together like that. Over the past, 12, 13 years of this meetup, we have gotten so many people jobs, and let's keep that going. So job postings channel. Self-servingly, since I'm on camera, I am hiring. I'm hiring for a data engineer. I'm hiring for an account executive. I'm hiring for a data scientist, a Shiny developer, part-time, full-time, New York, remote, wherever you're looking for. I'm hiring a bunch of roles, mainly data engineer and account executive, though we always have other roles open as well. If you want to apply for a job with my company, landeranalytics.com/careers, or message me on Slack. Get in touch. We're always looking for good people. So this wouldn't be the meetup without pizza. I got my pizza from Antimos. I'll try to get that in focus. There it goes, focus right there. Now it's been sitting on my desk for about 10 minutes, so we should have very good cheese lock. Let's see. Yep, good cheese lock, it's not falling out of place. Oh, lots of oil dripping. And we have some good charring on the bottom. This is a gas oven place. It's like a gas deck oven. So I hope everyone else is having pizza from somewhere fun. Let me know in the chat where you're getting pizza from, or if you're having some inferior food, let me know that as well. If you have some sort of great beer or soda or milkshake or whatever it is you want to imbibe in, let me know where you got that from too. We're always excited to know what people are doing. For those of you that don't know, and this used to be in person, every meetup we started with pizza and beer. And if you didn't drink beer, we had soda and water. And I miss those days. But every month I still get pizza. Hope to share with you folks. So I hope you folks have good food to share with me. We have a next few meetups planned. March 31st will be Bill Gold talking. He has a hybrid talk. Part of it's about the Brooklyn Bridge and how that relates to data science. And it's going to be really cool. So March 31st here on Zoom. Thank you to, by the way, EcoHealth Alliance for continuously providing us the Zoom for the past 2 years. And yes, this next month will mark our 2 years doing this virtually. March 2020 was our last in-person meetup, and March 2022, we're still virtual. That's Bill Gold, March 31st. We are hoping in April to be back in person and virtual. We will do both. We want to make sure people from all around the world can attend. We are hoping to have an in-person component starting in April. We're trying to lock down a venue. We have a few different places, our go-tos before the pandemic. We're hoping they'll let us in. We don't know yet. So if you have an office space in Manhattan that could hold 100+ people at 7 o'clock on a weeknight, let me know. Let Nicole know. We would love to use your space. And you could be there to welcome us for our first in-person meetup, which, by the way, the April meetup, if we return to in person, that marks the 13th anniversary of the meetup. So you want to host the 13th anniversary. You really do, especially once you hear the speaker. It's David Robinson. David Robinson is going to be for us here to return us back to in person, back to New York City, the city we love so much. And don't worry, all of you people attending virtually, we are still going to be doing virtual either on YouTube or Zoom, using Slack the way we're doing it now. We're going to keep this thing virtual for, virtual component forever. Before the pandemic, we tried live streaming. We couldn't get the audio to work out right, but we figured out the audio during 2 years of pandemic. So we're going back live and in person. I'm really, really excited. Hopefully it happens, assuming the Omega variant doesn't come or offices don't shut us out. So please give us an office space. We will announce the May and June meetup a little bit later, but we do have in June our in-person conference. We've had 2 virtual New York R conferences. we are very excited to have it back in person and virtual. It will be both. We're going to the French Institute in Midtown East. We're gonna have tons of food, tons of drinks, tons of just fun activities. We have great speakers coming. We have 2 workshops already announced, and we have 2 more workshops we're going to announce in the next week or so. We have great speakers like John Keane, Wes McKinney. We have Asma Toomey. We have Jennifer Hill, Max Kuhn, Andrew Gelman. It's going to be a great time. And by the way, folks, it is R and Friends. There's going to be a Python talk. There will be a SQL talk. Yeah, Python happens here. We'll have probably a Julia talk, and maybe not Julia. We've had that in the past, but I don't know if we have Julia lined up this time. We might have SQL or Stan. It's going to be R and Friends, folks. We're an open source programming meetup. The conference is R and Friends. So come one, come all. If you want to attend, go to rstats.ai for tickets. We have early bird special still running until I think March 11th. You can get early bird tickets. And on top of that, since you're a member of the meetup and this conference is meant for the meetup, you can get a 20% discount on top of the early bird by using code NYHackR. Just like the meetup name, NYHackR, get 20% off the conference. We'd love to see everybody there. It's going to be a really fun time. I can't wait to be back in person. And again, it will be virtual for those people who cannot travel to New York City. We want to make sure everyone is included in this thing. We've gotten really good at doing virtual stuff, so I can't wait to see everyone there in person and on screen. I'm really super excited. Again, barring any variants that destroy us again. Hopefully that will not happen. We might all just sort of, Nicole might lose it if we have to flip to virtual again on her watch. So we have that. Then lastly, questions. It's much harder to ask questions virtually, as we all know by now. So if you have a question about the talk, put it in either the meetup channel, and I'll give you that in a second, or the Zoom chat. So please go to our Slack, which I already gave you the link for. I think Nicole might, she hasn't posted it yet, nyhackr.org. You can find it from there. There is a channel called Monthly Meetup Chat, appropriately named. Ask your questions in there. Go in there, let me know where your pizza place is, let me know where your non-pizza place is, and ask your questions in there, because I can copy and paste. We'll come up with all the questions, the harder the better, and I will ask them all at the end. All right, so hope everyone is excited for this great talk. I'm very excited about this. We've had a series of talks about analyzing data that doesn't fit in memory. We've had Arrow, we've had disk.frame, I think we had another one. Now we have DuckDB, which I am super excited about. You hear all about this. And I believe in another case of me just asking someone on Twitter, do you want to speak? And of course, everyone's excited to show off the cool stuff they're building, because everyone's building this great open source stuff. We're all very excited. So everyone, please give a good emoji welcome to Hans, coming to us from halfway around the world at 1 a.m. in his time zone. So thank you very much for being here.
Thanks for having me. I'm really excited. Let me get going then. Good afternoon, I guess. My name is Hannes, and I'm here to talk about DuckDB, an in-process analytical database management system. Sorry for the acronym. It's something that I use every day, have been using every day for the last 10 years or so. So DuckDB is a new system we are working on. I'm going to tell you all about it. But first, I will briefly introduce myself. I work at CWI in Amsterdam, which is the Dutch National Research Lab for Computer Science and Mathematics. It's the place where Python came from. They always mention that. But somehow I got away with working on R a lot, so it was a bit weird. But never mind. I'm one of the 2 creators together with Mark Rasfeld of DuckDB, which is what I'm talking about. And recently we've also founded a spin-off company called DuckDB Labs around DuckDB, which is something that happens a lot in CWI actually, that you have a project, it goes maybe, it grows and grows and grows, and then it becomes a spin-off company because the research lab has other priorities, let's say. I am also a former Duck parent, which is how DuckDB got its name. And I live on a ship, which means that I'm speaking to you from this floating object right now that looks a bit janky maybe from the outside, but I can assure you it's perfectly safe. Okay. Let me get started. So I have sort of 3 main topics for you tonight. The first thing is the general strained relationship between data scientists or statistical programmers, or whatever you want to call them, and database management systems. We'll talk about what DuckDB is, and I will also do a live demo of general behavior of the thing, and obviously try to demo some properties of the system that I think are interesting. Yeah, and of course, I will also answer any questions you might have. I'm really happy. I'm really curious to hear that about those. So if you have any questions, as Jared said, let him know. Because really, you know, this is your opportunity to ask me anything. All right. This is kind of interesting. The strained relationship of data scientists and data systems. So data scientists work with data. I think there's a lot of, lot to argue about data science. But one obvious and not so controversial thing is that they work with data. And my field, I work in a database management systems research lab, has been spent 50 years, all the way back from System R from IBM, has been spending 50 years on perfecting database management systems. So it's clearly obvious that data scientists use database management systems, but they don't. They really don't, and they will sometimes interface with database management systems if they're really forced. For example, this common case of corporate data sitting in a database management system already, like in your Oracle or whatever, and you having to deal with that in order to do actually your work. But people generally prefer to avoid these systems in general. There's this nice quote from Hadley here that it says, if your data fits in memory, there is no advantage to putting it in a database. It will only be slower and more frustrating. And that really hurts my feelings. I think, as somebody who cares deeply about database management systems, that really got us thinking. And it's these and similar quotes, of course, have really been the, let's say, the motivation to build DuckDB in the first place, which is, I'll get back to that later. But let's see. Maybe data scientists don't really need database management systems. So but then I've just actually run this data for you today. So then let's have a brief look at the most downloaded R data wrangling packages, January 2020, from the RStudio CRAN mirror logs. And we look at this and we see this table where you have on the left column, you have the rank in the download popularity, in the middle you have the name of the package, and on the right you have the download count. And you can see that you have dplyr number 5, data table is number 31, arrow 415, and of course DuckDB 1113. That there's this clear need for this kind of technology also in the R space. So if you ask yourself, what do, let's say, dplyr, data table, and arrow, and there's many others, have in common? Well, they kind of perform relational operations. It's really strange how this maps super directly to what you know from relational systems, like selections, projections, joins, aggregates, unions, ordering, mapping scalar functions, the whole thing. This is one aspect. The other aspect is the support of I/O, let's say, like loading data into R, writing data into files. For example, like loading things like CSV Parquet files into R. There's also an interesting aspect. So from this, we can kind of conclude that the data sets actually need DBMS functionality. It's just that they really don't like database management systems. It's really interesting. And the result is that the community is kind of reinventing database management systems, but I hate to say this, but rather poorly, from my admittedly ivory tower perspective as a database systems academic. For example, there's no notion of holistic query optimization, right? So if you build a dplyr pipeline or a multi-step pipeline data table, doesn't really matter. You will not have a query optimization step that looks at the entire pipeline and tries to be clever about it. It's just going to be a materialization after each step. And that leads to materialization of potentially huge intermediate results, which is a problem because it's generally also these things do not support out of memory computation. So that means because you materialize large intermediates and because you don't support out of memory, generally that means things stop working, to put it simply. There's also little parallelism. I mean, this is changing a little bit, but overall, because of this single step notion, we also don't have pipelining, which is kind of not the state of, which is kind of the state of the art in parallel data systems. There's also something that I've also wondered a bit about is that there's also no notion of transactional storage. So people have somehow completely gotten used to data management sort of semantics from the 60s in that sense that, oh, I'm writing to this file, but my R process crashes halfway through. So now I have half a file somewhere and I have to deal with that when these are all like solved problems with transactions. But somehow those are not used. So state-of-the-art analytical database management systems, they have kind of solved all these problems. And with these, even considering the usual gap between academic research around those systems and what is actually deployed on the ground, there's actually a lot of firepower available in systems. It's just that indeed the current systems that people are using, they can indeed feel very slow and they can indeed feel very frustrating. But what we kind of set out to do is to work on this part. Why are they slow and frustrating? Because they don't have to be. There's no reason why, for example, the client-server interaction between you and your Postgres server has to be so slow to be practically unusable for large data sets. There's no reason, you have to first pay an Oracle consultant a lot of money in order to set up a high-performance data management system. There is no reason why a CSV parser in a data management system has to be the most complicated thing to run since the dawn of time. There's no reason the database systems have to own all the data. They can also just run on anything else, and this is really not such a huge step. So this is the kind of the motivation to rethink this a bit, and so that's kind of how DuckDB came along. So what is DuckDB? So DuckDB is something we call an in-process OLAP DBMS. So again, more acronyms. OLAP means online analytical processing. It means it's what we do in R. It's data analysis for analytical purposes. The other standard database use case is called OLTP, which is transactional processing, which is something that Postgres, for example, is good at. So DuckDB is OLAP, so analytics. The DBMS is database management system. Okay, it is in process, and that is something that is quite uncommon. And the only other system that is of note that is also in process is SQLite. And what is different from, let's say, Postgres or MySQL or really anything else is that the database management system runs within the process you're trying to access it from. In this case, this would be R. And we have a slide later where I could talk a bit more about that. DuckDB is written in C++11 for maximum compatibility. We got a lot of questions, why not Rust? But yeah, maximum compatibility. And DuckDB is a SQL system. So that means that it speaks SQL, SQL in a general case. More specifically, we have adopted the Postgres syntax. So yeah, it's compatible with Postgres SQL. On the language level, that's like the compatibility. DuckDB is also special because we have adopted the principles of the Tinyverse and built it without any external dependency. And this is something that comes a bit from my life at CWI, where our evil admins would not allow us to install anything, and it wouldn't give us root permissions on our cluster machines. And this was also before there was something like Docker or something like that. And so we had to, suffer a lot every time something had an external dependency. And from this experience, we developed this deep hatred of external dependencies. And as a result, DuckDB doesn't have any. And it turns out that we are not the only people that don't have root on their boxes, which is obviously not very surprising. So even for people that don't have root, they have maybe the rights to install R packages, they can use DuckDB. DuckDB is integrated with lots of stuff. So this is just we can talk to C, C++, there's a command line client, there's a Python interface, there's an R interface, there's Java Node, and so on and so forth. There's a lot of contributed clients as well. I've kind of lost track of all of them. Suffice to say is that you probably will find a way of talking to DuckDB from your favorite language. Of course, your favorite language is R, and so is mine. So that's good, because R is the, I would say, a focus of DuckDB development in general. DuckDB has native Parquet support. We figured that it's, in 2022, a large-scale data management tool probably needs to be able to speak Parquet, so we can read and write Parquet files natively, again, without any external dependencies, which was fun. And DuckDB is also integrated with Arrow, which is interesting, I think, because we actually have a collaboration with them, with the Voltron data people, on improving this Arrow support. And what we can do there is we can basically pretend like an Arrow table is a table in DuckDB and run queries on it, any query. And we can also export our query results back as an Arrow table. And this doesn't only work, it also works in a streaming way. So we can actually stream through DuckDB, we can stream Arrow data and kind of round trip it without actually materializing it ever. Of course, depending on the query, some queries have to materialize, but for many cases we don't. And this is quite an exciting integration. Testing, yeah, DuckDB. So many sort of research labs are kind of notorious for producing software that maybe proves a point, but isn't terribly useful or still needs a lot of work. So if you look at Postgres history, for example, when it came out of UC Berkeley, it was practically unusable. And it was only the long sort of iteration and slog of open source contributors that made this usable. We thought maybe we can shortcut this process, and we designed it from DuckDB from day one to be actually, something that people can use. And to make it something that people can use, we had to create this giant test suite of millions of queries that we run on every commit in order to make sure the thing still does the right thing, TM. And that is, I think, something that is it's pretty rare, let's say, for this kind of project. It's pretty common, though, for commercial systems development. Yeah, DuckDB is free and open source. This is something that is also a bit uncommon, let's say, in this space, especially under a license like MIT license, which is very permissive, of course, because the technologies that you find in DuckDB, they're quite rare, I would say, in the open source space, especially in this combination. We'll talk a bit later about what those are. Because this has so far been sort of these technologies so far have only been found in, or mostly been found in, quite expensive commercial systems. Yeah, so I mentioned this briefly. DuckDB is optimized for analytical use cases. So OLAP. So how are these characterized in more detail? Well, OLAP is characterized by being mostly read mostly, it's called. So where your workload, we call that sort of the overall set of queries that you run on your system. Yeah, you run a lot of selects, and these selects tend to touch a lot of your data. So if you run a query, you will run on entire columns, or you will group over an entire table, or you will join an entire table with another table. And yeah, so these are fairly complex queries that touch a lot of the data. You will, in terms of updates to your data, you will see mostly bulk appends, bulk as in we'll append 1 million rows to your table, or we'll change an entire column of your table. And it's kind of interesting because in DuckDB, we have redesigned the MVCC transactional control mechanism to actually deal with bulk updates. And I think it's the first system out there that does that. And the result is that you have full transactionality on data stored in DuckDB with regards to, oh, I can start a transaction, start doing this massive update of my data, decide that I'm going to change my mind, and roll this back. All the while, 15 other transactions are running that are looking at the same table without interfering with each other. I mentioned before, there's something that has kind of been lost in the let's build our own data tools craze. And this is different. So this OLAP scenario, that's quite different from what traditional systems are designed for. So if you look at Postgres or MySQL or SQLite, those are transactional systems, which means that they have been designed to support very many millions of very small writes and updates and very many millions of very small queries. Like, okay, let's pull a single row from the table. Let's pull a single row, update this one field, and then write it back, or let's delete a single row. And this is a very, very different use case than analytical queries. And it leads to very, very different trade-offs when you're designing a system. You have to use very, very different data structures, very different data encodings. You have to use, different paradigms in overall in building these query systems. Yeah, and as I mentioned, DuckDB is tightly integrated with R. I will show that later, but this has really been something that has been close to our hearts from the beginning. So I think DuckDB had an R API from like, week 3, because it was important to us that whatever we were building fit well into that environment. And we have actually made a ton of design decisions, for example, with DuckDB, so it's still possible to publish it through CRAN, which has, as you probably know, tons of restrictions regarding what kind of code you can use in your package if you're not cheating. So why not something else? Isn't there anything else? Well, there are other systems. So there is the existing big data ecosystem. For example, you have Spark, you have ClickHouse, you have Presto, these kind of things. But and it's kind of funny because sometimes I teach courses. Right now I'm teaching a course with Spark, and it's amazing how difficult to use these things are. So first of all, you have to install these multi-gigabyte packages of stuff, usually Java files, have literally hundreds of external dependencies to install before you can run something like ClickHouse or Impala or whatever. You have complex setups. You need if you want to have multiple computers to run this is really nightmarish to set up. And once something goes wrong, the debugging step is where I personally lose my mind every time. So I find it a bit regrettable that these existing systems are quite hard to use, which kind of harks back to the quote from Hadley where he said they are frustrating. Yes, they can be very frustrating indeed. Then you have also the Dask kind of pandas plus crowd, and those are better, let's say, because they're more lightweight in general, but they also lack optimizers and therefore cannot do complex queries without a lot of hand rolling, and that is also not very pretty. So this is the existing ecosystem is not something that, let's say, has convinced me from a usability standpoint. And yeah, as I already mentioned, you have this existing SQL landscape, and there's usually OLTP heavy. So in-process systems that exist, for example, SQLite or Pandas or dplyr, they are also not big data capable in that sense, because you have single thread execution. You have this transactional notion of operation, especially with SQLite and Postgres, which really leads to something we call a high CPU cycles per value cost, and therefore very bad performance on large data sets. And these systems also don't really take advantage of modern hardware, which DuckDB does, and I'll show you later how it does that. And there's this sad hidden truth, kind of, that in-process OLAP can support like 90% of big data workloads. There's been a bunch of papers on this, on looking at the actual workload sizes of typical big data analysis. And the sad truth is that 90% of these workloads can totally be done on a laptop. The only reason why people don't use a laptop, why people use Sparks, is because of the limitation of existing tools. And it's quite surprising to see how far you can stretch something like a MacBook with something like DuckDB, without going to a Spark cluster, we had this, did this experiment where we looked at this, the famous New York taxi data set. And we compared we measured how many Spark nodes you need to beat DuckDB on a single machine on this data set. And I think the answer was 32. So you needed 32 times the hardware on Amazon to beat the single node, sort of to beat the performance. And that was, I thought, quite shocking because, we'll basically burn 32 times more polar bears in order to use Spark. And then the question is why, right? If it's not necessary. Yeah, so here's a picture that I like to use to explain where DuckDB fits into this general landscape. We have the in-process and the standalone systems, and we have the OLTP and OLAP divide. And if you think about it, SQLite, the world's most deployed database system, is an in-process OLTP system. Postgres, I think the most popular open source database management system, is a standalone OLTP system. And then DuckDB, of course, is kind of the first in-process OLAP system, actually. So we kind of invented that category. And if you wanted to have another representative of the standalone OLAP category, you would think of something like ClickHouse, right? The problem with the standalone stuff is that you always have the client server set up to deal with. And that means that if you were running a database server just simply for yourself, you have to set it up. And you have to deal with the client protocol pains, which I already briefly mentioned, which means that when you try to pull data from the standalone system, it will take ages essentially, because all the data has to go through a socket and use in case of Postgres using ancient row-based protocols. Maybe this is all fixed now with Aeroflight SQL. We shall see. Yeah, so DuckDB adoption and use cases, maybe just a bit just to show where we are. We have about 100,000 downloads a week right now. Most of them come from Python. It's about 4,000 GitHub stars. It's going very well. We are quite happy with the adoption on there. 400 forks, which is sometimes, I wonder why people click the fork button, but that's a different discussion. And we can see two kind of main use cases for DuckDB at the moment. One is the scaling data science workflows use case, where, as I just mentioned, you can kind of expand the capabilities of what you can do in R to far beyond what you would have thought would be possible. And the other use case is that people use DuckDB as a building block in very large data science pipelines or other systems. So we're working with a bunch of industry players there that basically use portions of DuckDB in bigger systems. And that's also how we, by the way, finance the DuckDB Labs operation. Yeah, but we are here for the first bit, scale the data science workflows. But how does it do that? How does DuckDB actually manage this? And I'm going to talk a bit about the internals and how DuckDB manages to be faster than the others. So I have to talk about query processing paradigms. The first query processing paradigm is tuple at a time. And this is probably the query processing paradigm that you think that all SQL systems out there use. So we have, for example, systems like SQLite, Postgres, MySQL, etc. They all use tuple at a time. And it's really a great method if you are running transactional workloads, because it gets you a very small memory footprint. You can literally get away with a static memory allocation, which is what SQLite can do. And this paradigm also kind of comes from a time when we didn't have memory. But the cost of tuple at a time is that we have a high CPU overhead per tuple because we're going through the data in a row-wise fashion, which means we have to constantly switch around between the types that we look at while going through the rows, because we're not going through the data in a column major way, but in a row major way. And that's fine for transaction. That's actually great for transactional workloads. It's what you want to do in transactional workloads. But yeah, you get the high CPU overhead. So if you're going through a trillion rows, it's going to be slow. The next query processing paradigm historically was column at a time. And this is actually what's happening if you use R data frames. Because in R data frames are just lists of of vectors in R, and vectors are just columns of native C arrays in memory. And that worked better. So that gets you a better CPU utilization for your queries. And it allows to use to advantage of modern hardware. For example, you're able to use SIMD instructions on your data. But it also has a disadvantage, because if you look at column at a time queries, and you look at longer pipelines that use column at a time, it materializes huge intermediate columns in memory, and they can be gigabytes in size. And this gets really problematic when data sizes are large, because it will push you beyond the memory limits very easily. It's kind of funny. Side note here, I talked to John Chambers about this once, because I happened to make a snarky comment about how R got this right by accident to use a columnar representation. And after the talk, he came to me and informed me in a very friendly way that this was not by accident. It's a bit okay. Sorry. But DuckDB uses a mixture of row-based and columnar query processing paradigms, which is called vectorized processing. Now, there's always a bit of confusion there, because people think vectorized means SIMD, but it actually doesn't mean that in our sense. What it means is we look at data, we process data as a stream of subsets of columns, sort of chunks of a table. And this has huge advantages with regards to CPU cache locality. And it allows, for example, also to use SIMD instructions. It allows you to use pipelining with regards to pipelinable queries, but it doesn't fill up your memory. It uses very small intermediates. Our intermediate results in DuckDB are usually 1024 rows in size, and that means that the intermediate fits in the cache, which means that you can actually do a lot of operations on a single vector, we call it, of data, without having to go back and forth from memory, and which is where the speed comes from. Okay, so in vectorized processing, the intermediates fit in cache, which is great, which is fast. And the reason for that is that you have this cache hierarchy, where you have these various layers of cache. You probably heard of L1, L2, L3 cache. And if you look at these cache hierarchy, you see that you have L1 cache, it's very small, 32 kilobytes, but the latency is 1 nanosecond. Great. In memory, you have maybe, I don't know, 64 gigabytes on the latest MacBook, but then latency is 100 nanoseconds. And this 100x difference there really makes a huge impact when you're constantly going back and forth between the two. And now with vectorized processing, all the things you do fit into these high cache levels, so you don't have this problem, and it makes it really fast. And in the column at a time approach that I've mentioned before, you are kind of forcing intermediates to go to memory once you do anything serious, which means that things get very slow, regrettably. So that's kind of the magic sauce, the kind of low-level hacking C++ kind of engine perspective. Of course, there's a ton of other things, but that's at the core of why this is different. DuckDB loves R. It's as I mentioned, it's kind of interesting that I'm talking about DuckDB at an R meetup again, because we also announced DuckDB at an R meetup a couple of years ago in Zurich. And indeed, much of the motivation to build DuckDB in the first place came from interaction with R people. Especially, there were two, I want to mention two people. There's Thomas Lumley and Anthony D'Amico. And these two both were actually working on analyzing survey data, specifically the American Community Survey, which, because there are many Americans, the survey is quite large. And they wanted to find a way how to analyze the survey data set without, because it wasn't possible in R anymore. And that kind of led to a long kind of working on things together, first with external, like standalone systems, and then with this daft idea of in-process OLAP, which kind of was developed as a result. And yeah, DuckDB is the result of these interactions, which is kind of cool. Because it's also something I think in my field that is quite rare, that people actually talk to practitioners. It's quite common for people to develop systems, put them out there, and are then surprised when nobody cares, because they actually haven't talked to anyone, and they sometimes have this notion of that the world has to, I don't know, come to them more often to acknowledge to people their brilliance. But we see this a bit differently, and we think it's this interaction with people that makes it better, which is also one of the reasons why DuckDB is open source and why everyone can complain to us on GitHub. Yeah, so DuckDB is on CRAN without external dependencies. It fully implements the RDBI. Sometimes we talk to Kirill, who is of course the guardian of the DBI, and we have some arguments, but I would think he would agree that we fully implement this API. DuckDB supports dbply. We've just recently merged a big pull request that extended these capabilities, but in principle, because DuckDB speaks SQL, there's no sort of, how should I say that? There's no problem there. You can just, dbply will just be able to create SQL queries that DuckDB understands. And one really important thing that makes DuckDB different from, I think, every other database management system is that we can efficiently transfer data to and from R. And how do we do that? So in DuckDB itself, we have implemented readers, what we call a scan operator, for our data frames, which means that, yeah, we can pretend like an R data frame is a table that we operate on. And we can actually, in many cases, zero copy the data from the data frame into our internal vectors that we use for query processing. And on the other side, this also works. I mentioned this, that we support this with Arrow, but we also support this with normal data frames. So we can take a query result in DuckDB, and we can efficiently turn it into another R data frame. And I think it's pretty unique in that. Let's say unique in that is a general purpose data management system that is deeply integrated with R to the level where we can read native data frames and write native data frames without a lot of loss of speed. Obviously, when we talk about data frames, we have to mention one thing, which is strings. So strings are usually a curse, but we have had a quite long running interaction with the R core team and friends about this. So in 2014, I demoed zero copy DB database and R integration at a DSC meeting, and this was more like, okay, people, this is what could work possibly. Maybe we can, work together on something. This led to 2016 the ALTRAP framework being proposed, also at DSC, and then it released in 2018. And we were now in 2021 able to use the ALTRAP framework that we proposed in 2014 to make string transfer from and to R and DuckDB fast. And it's kind of funny to see that, like how long this interaction ran to produce this outcome, because when I would have never dreamt that we will ever be able to benefit from this ourselves, but here we are, and we have. Okay, so this was a bit of an overview of what DuckDB is and how it works, and now I would like to go to a demo. So there's a chat message here, but I suppose it's a question. Oh no, something else. Yeah, so I have my shell here. I hope you can see it. I will start R, and now I will get some script I prepared earlier and start doing things. So here I'm just loading DBI, which is the R standard database interface. They're making two connections. One is to a Postgres server that runs locally on my Mac here, and one is the DuckDB connection that runs inside this very R shell. So if I look at this connection, you can see that there's some funky things here, and these are just the pointer addresses of where the database lives. But this is not an in-memory database like what you maybe know from SQLite, but I'm actually using an on-disk data representation for fairness. So let me create some dummy data. So this creates a data frame with 10 million rows, which is not that crazy, right? But it's also not very tiny, of just random numeric values, columns A, B, C. And now let me do the first experiment. I just mentioned that DuckDB was very good at reading data, transferring data to and from R. Now this data frame I just created, also named it data, lives in R, right? Let's try to put this into Postgres. And now here's a command that will write this data frame called data into my Postgres SQL server that I have running here on my computer. So this is not like remote or anything, it's just the same machine. And I'm just going to write this in. And now it's done. And because of this time thing here, it will print the time it took. So 12 seconds. So this is not a crazy large data frame. We just wrote this into our Postgres server and take 12 seconds. Okay. You might think this is not a lot, but obviously then I'll make the data set bigger. If I do the same thing with DuckDB, we're done in 0.4 seconds. And why is this so much faster? Because this is effectively also just writing. I mean, in the end, both of these commands write to disk because they tell the database management system to write a new table to disk, which, on the same machine, the disk speed is constant. So that's not the factor. The factor is that, of course, two things. One, it's the client server overhead that happens when I talk from R to my Postgres server. And second, it's that DuckDB is just also generally faster of writing tables to disk. So now we've already seen one experiment. Let's do another one. Let's do the other direction. Let me pull my data frame back into R from Postgres. Now this is should be a bit faster because it's reading, not writing. And you can see in roughly 6 seconds, we were able to read this data frame back into R. And now we have the same. So if I look at, we should have our 10 million rows back. And we do. Okay. Now let's read the same data frame back from DuckDB, and it's 0.1 seconds. And this is really a game changer. So what this allows you, for example, is to really pull huge amounts of data from persistent storage into R, do some operational, and then write it back in a transactional way without having to wait. And this allows, for example, iterative computation and things like that would otherwise not be possible. And now just for the lols, I'm fitting a linear model to this data, and which takes 1.8 seconds. And this is kind of what I'm, it's just as a comparison. So if I spend 1.8 seconds to fit a linear model, but I've just spent 6 seconds to load the damn data, that seems a bit like an imbalance. You would think the fitting of a model is more complicated than reading a data set. And it is, which is why if we read this thing from DuckDB, it compares much better because it's only 0.1 seconds to read the data versus 1.8 seconds to fit the model. Seems fair. Let me talk about strings. I've mentioned strings are a bit of a curse. So let me just now run a bunch of queries where I'm just going to cast one of the columns in my data set to a string, but I'm going to do that in database, so on the other side of the fence, so to speak. And now I have to wait again. Yeah, there we are. Okay, so now both systems have done that. and converted 10 million strings. It doubles to strings, which is somehow also slow. And now again, I can run this timing of the pulling the data. Now it's just one column from Postgres to R, and I will run the same thing in DuckDB. So here now we took 8 seconds for the single column, which I think is pretty bad. And if I do the same thing in DuckDB, it's only half a second. And actually, I can use this. I can show you this. I can actually show you this this low-level print of the structure of the object, and you can see that here at the very bottom of this data frame, you don't have an actual normal string column, but a DuckDB string column, which is an altrap object that looks like a normal R string vector, but actually isn't, and it will like delay the conversion to an actual R text for performance reasons. So this is why DuckDB is much faster there. It's because we use altrap, which we invented ourselves, which is great. Let me show you a bit the DataFrame Scan. So in DuckDB, what you can do is I can, of course, I have this infamous mtcars dataset here. I can say, please register this data frame, mtcars, in my DuckDB connection under this name, mtcars. And now what I can do, I can run queries. So as you can see up here, now I've just given this an arbitrary SQL query. This is the most common SQL query, of course, is SQL select star from table. And it's reading from this mtcars table, which I've just registered up here. And the cool thing is that this register step actually doesn't copy anything. It just registers the fact, and I mentioned this earlier, DuckDB can directly read data from our data frames. It just directly registers the data frame in DuckDB and says, okay, DuckDB, listen, there is a data frame, mtcars, that you should expose to SQL users under the name mtcars. And you can really run any query here that you like. Maybe I can show you an explain output that shows, never mind, this is fixed in the latest master, but not yet on the CRAN. If you look at the query plan, you will see that on the bottom of the plan, where normally you have the table scan, it will say our DataFrame Scan. DuckDB can also read Parquet files. So if I just I will just show you that as well. So if I just, sorry about that, I have to find the link to a Parquet file here. So I can also do something with DuckDB with the DB get query. This is just normal DBI, right? So DuckDB select star from, and now I can just use the Parquet file name as a table name, and this is something that works in DuckDB. So I will just point this to the Parquet file and say, I don't know, limit 10. So it's condd, sorry. And as you can see, now I have the result, like some columns that come from this Parquet file. And again, this does not actually import the data into DuckDB. I'm just creating a scan over a Parquet file, and it works because DuckDB has built-in support for Parquet. And we know that this is a Parquet file because we look at the table name that you're using in this query, and we find that we use this extension. You can also make this explicit. Also works with wildcards. Also works with S3. You know, whatever. Okay, let's do more experiments. I'm gonna read another data frame from an RDS file, which is called line item. This is a data set that is a synthetic data set from the TPCH benchmark. Yeah, it's a benchmark data set that is used a lot in data management research. And it's something that, yeah, we also end up using a lot. So here we have the line item data set. And now I can use this waiting game again to write this data set, which has, I think, something like 6 million rows. You can configure, of course, how many rows you want, but for benchmarking purposes, I just use the 6 million size. Now, again, I have to wait till this ancient Postgres technology has managed to transfer this data set over the socket from R, because this data set I've loaded in R from the RDS file. Now I just have to wait until this is being transferred. And now I should have a, what is it? The Jeopardy waiting music or something like that. And this is really the worst part if you have a live demo and something takes a while, because this feels like much longer than it does when you try this out. But I hope it's done soon. Hopefully it doesn't crash. There we are, 42 seconds. That's kind of perfect, isn't it? And now let's do the same thing with DuckDB. It takes a little bit longer because there's more string columns in here. But 4 seconds, yay. And now let's have a look at this data set using dplyr. So I have I'm just going to copy paste because I can't type this fast. I'm just going to have a function here that does a bunch of quite common data operations. So it will filter the data here to say, okay, this column needs to be smaller than this date. We do a group by and a summarize, where we say, okay, we group by 2 of these columns. We do a bunch of summarize computations like aggregates. Then we do an arrange, sorting, and print the result. And now I can, of course, run this directly using dplyr. And this is the same. And I can also run this using dbplyr. And as you can see, I get the exact same result. What I can also do is I can run this through, I could also run this through the DataFrame Scan directly. But yeah, that's a different, that would be the same result again. So that's that. So that was the demo. Let me get back to my slides. I actually don't have I only have a Wrapup slide here. And so if you, just as a, please, if you want to hear more about DuckDB, you can join us at our user group meeting, our first one, which is in April. We have a Discord server. You can follow us on Twitter. But before you do that, I'd really like to discuss some questions that have come up. And 2 have already come up by Jared himself. Maybe if you like, we can also discuss what kind of things we think are gonna be added to DuckDB in the next year or so. But 2 questions came up already were, what about GIS support, geographical systems? And this is something that we're working on. It's not entirely clear yet, because the problem with GIS and databases is that PostGIS is this kind of state-of-the-art thing, but it's using Postgres. And as I just explained to you, Postgres really is not great for analytical use cases. And Postgres as an implementation is quite row heavy as well. So we don't think we can use it. So we'll have to do something else there, but we're working, we're also looking at the developments in the aerospace on that, and kind of curious how that goes. And that's also the JIT question. And that's actually a different question. I think it was a GPU question. Does DuckDB have GPU support? It does not. We don't think it's necessary. It's fast enough as it is. But with that, I'd like to hear some other questions. Maybe I can stop sharing my screen for a bit here.
So thank you very much. Everyone give a nice little emoji clap in the chat. Let us show Hannes our appreciation for this great talk.
Thank you.
Yep. So I know I already got some not questions but comments about people who love the Tinyverse reference there. Or actually, could you explain to people who a lot of people are going to be very aware of the Tinyverse, but fewer people are probably aware of the Tinyverse. Could you maybe just let the crowd know about that?
Absolutely. So I'll just show you this this is something that is a bit of a rant by a bunch of people from the art world. I think this is where it comes from. And it's also a bit of a stab at the Tinyverse. So I don't want to get into the into sort of the the details of that beef, but the Tinyverse, the idea is that we should be careful with dependencies, and I think that is a good idea. And it says on this website, tinyverse.org, it says every dependency you add to your project is an invitation to break your project, and it's something that me, like being software developer for, I don't know, 20 years, have learned too much how true this is, let's say. And it's also why I'm super wary when I see systems like ClickHouse or Impala, and they have hundreds of dependencies in order to just build and run them. And that's just such an extremely brittle setup. And it takes only one tiny little thing to change, to make the whole thing come crashing down. And this happens a lot, which is why nowadays you can't actually build these systems anymore yourself, because the environment that they need to build has degraded so far that the only way to build them is through their Docker container, for example, which you might say is not a big deal, but it is a big deal if you want to be a CRAN package, for example. Now on CRAN, in R, it's actually quite convenient to add dependencies to your project, and thanks to the tireless efforts of the CRAN maintainers, of course, the package quality generally is okay compared to other things. However, the same thing applies. Right now we have giant reverse dependency trees, and before somebody can change a package, these enormous checks have to run, and they still miss things, and they still break people's things, and this problem just multiplies. And I guess statistical people should be not surprised that if you add more dependencies, then this problem becomes much worse, superlinearly worse, let's say, because of just the chance of anything breaking in one of your dependencies. And something that many people don't realize is also the transitive dependencies, right? Because you depend on something that depends on 10 other things, and each of them depends on 10 other things. And there's actually this, we get this hairball of a graph, a dependency graph, that basically means at some point everything is dependent on everything. And yeah, nothing works anymore. So we've made a very conscious decision to limit dependencies to one. We have one CRAN package dependency, which is DBI, which we kind of need to have. And it's also an R-only package. And otherwise, yeah, this is really important to us. And I think, it's just because I have personally suffered so many times trying to install things, that we've really tried to keep this, to learn from SQLite and just have no dependencies.
It's funny, one of those supporters of the Tinyverse, Dirk Edelbettel, he's written the package probably is the most dependent on. RCPP has like 8,000 reverse dependencies because it's such an important package.
Yeah, this is not his fault though.
No, it is his fault for making such a great package.
So, well, it's not his. I mean, okay, but of course, then imagine, then if Dirk starts depending on rando stuff that breaks, he breaks every single package that depends on him. So I think that's really a problem.
And if people want to learn more about this, we had a talk at the conference a few years ago by self-described town crank, Jeff Ryan, about how your API is a promise and about not having dependencies. And I remember I very purposely scheduled Jeff Ryan's talk to be right after David Robinson's talk, because they were complete opposites of each other. And that was really fun. And one of my favorite photos ever, JD Long took a photo of them at the bar, Rye House, afterwards, of Jeff and David like going at it at the bar with whiskey in their hands. And it was a really, really great picture.
I think this is true. I think it's fine to depend on tons of stuff. If you're the lowest in the tree, if you are writing your own package to do something that you need to do for your work, if you depend on 100 things, fine. If this breaks, it's only you are affected. But if you're building something like DuckDB, which is supposed to be a building block for tons of things, we have to be much more careful. So I think the zero dependency is also much more relevant if you are building a library that other people depend on than it is if you're building, a end user thing.
Of course, even as an end user, if you are a scientist and you need to go back to your work 6 months later, but all of a sudden something's changed, you as a scientist need to relearn that part of R, but you're supposed to be doing like chemistry or something.
Yeah. And then you have things like, people not updating packages for this reason, or like snapshotting packages with Docker in order to work on this problem, which, both solutions I'm not sure about. It's
Cool. So I know we had fun getting sidetracked there. Let's continue on with the questions. This isn't a question, but Brian Lewis is in the crowd, and he was there, it looks like, at the 2016 DSC discussion about alt-rep. So he just gives you a comment. This is more awesome than he could have imagined. So that's not a question, but a great comment from Brian Lewis, another longtime member of the community.
Yeah, that's super cool. Yeah, Brian. Hi, Brian. Yeah, this is really something that I didn't expect. Yeah, I said this. I mean, this was super cool. I'm also big shout out to our core team for making this happen.
You mentioned, you already cut me off at the head about the GIS, because I've been pinging you about that on Twitter. But until the GIS analytics is ready, I have a question. This is from me now, not from someone else. Is my question. Can I store a geometry column, or for that matter, any custom column in DuckDB? I won't use it for processing, but I want to store it.
Yeah, of course you can. There's support for blobs, which are just binary objects. However, this is a bit suboptimal, because then you have to kind of find a way how to transform complex things to serialize and unserialize. I think what's nicer is that we have this support for structured things. We call them structs. They are nested types, so you can make a type that is a string, an integer, a list of things, and another string or something like that. You can define these types, and then you can basically map your custom thing to that. That's usually what people would do with custom stuff. It's also how we expect to support the GIS structures kind of as a struct type. We call them struct types, a bit like C structs. Mm-hmm. And the cool thing is that we can actually store these structs also in a columnar way. Therefore, it's fast to process on them.
Oh, wonderful. And I'm going to ask selfishly, can we have a timeline on that? Like 2 days, 2 weeks, not longer than that?
On the GIS?
Yeah.
We have an intern starting on this. But I think there's a lot of low-hanging fruits. We also depend a bit on the interaction with the community. So on what is actually something that you need to be there for this to be useful to you. So that's something that is still a bit up in the air, I would say.
Okay, cool. I will pester you more on Twitter so we can ask other people's questions. How would this DuckDB, this being DuckDB, handle time series data, and both storing it and also computing on it?
This is a very good question, because we have Richard, who I think is here, who has been working a lot on window functions. And this is, I think, the way in which SQL databases are gonna demolish the sector of specialized time series databases that have sprung up in the recent years. Because I'm not sure if you're aware of window functions in SQL, but you are. Okay, so those can do a lot of the things you would normally want to do on time series, because they have this notion of going over the data in a kind of a localized kind of way, and you can look in the environment of your row and things like that. You can also run like folds, and you can run custom functions. We're working on making custom functions possible on window functions. And I think that's the way that this is going to be won, is by general purpose systems, basically making window functions fast, which we have. Richard has done a lot of work on that in DuckDB. There's still a lot to be done, but I think it already works perfectly well to do time series analysis. We still have to work a bit on the user interface. Let's say, what if you have a custom function you want to run as part of your time series analysis? And we have to do a bit of still more performance engineering on them as well. So but in general, I think it's the way you should go. You should do like normal SQL for time series stuff.
I'm going to throw in here, the only thing I'm worried about, window functions are a pain in the butt to write. Right? They're ugly compared to regular SQL. So you can find a way to make it less ugly.
But I mean, maybe we can map this to dplyr somehow, and say, okay, here's an API for window functions that we expose to R that makes this. Package. I'm sorry?
The slider package by, I think Vaughn Davis implements that. That might be your.
I'm not entirely aware of this, but yes, something like that, where you have a nice API on. Yeah.
And I believe in addition to the slider package, which is like, it's like per, but for sliding windows, there is a, I think an RCPP role by Kevin Ushi. And I believe probably XTS probably has something. So there's lots of things you can get inspiration from.
Yeah, I think this is super interesting stuff. I mean, I haven't spent a lot of time on it myself, but we've been talking to people that are in the kind of the time series world, and it seems to be the way to go.
Yeah, because I know there's a lot of like, there's the old history pi databases, but now there's like InfluxDB and timescale.
Yeah, which by the yeah, exactly. But I think this is another case what I complained about with the R community reinventing query processing, where the time series people now reinvent query processing for one specific purpose without realizing that they're just basically rebuilding systems that exist that are not well suited yet for their use case. But yeah, that's just a bit of a rant there.
So since you have a analytic database and for computation, does it already exist? And if not, is it in the pipeline to be able to fit like regressions in database or boosted trees or any other learning algorithm?
We do have regressions actually.
GLMs?
So I'm sorry?
Like the whole full GLM family?
No. We have some basic regression in principle. The story that we have there is to say, because the data transfer from R to R is fast, you can do a lot by pulling the data, which would be not possible with other systems. And of course, whatever you can express in SQL, you can do. I think what this is the way this is gonna work is by people building wrappers that to ship part of the computation to the relational model in terms of SQL queries, and then use a bit like what H2O is doing, and then use some logic on top to finalize the computation. I think that's the way this is gonna end up. But yeah, we have a ton of aggregate functions that are specialized to support these kind of use cases. So for example, we have things like the basically of these quantile computations. We have all these regression, like the linear regressions. It's all built in. I can post a link if you like. Please do.
Or show us an example of a regression of C on DNA.
This I cannot pull off. Sorry, in ad hoc thing.
Fair enough. Okay, because that's really exciting. Having been like, you say you can move the data out fast, but sometimes the data is just too big to pull into memory. So it'd be nice to be able to do the regression, a penalized regression even, right there in the database. All right, cool. I'll add that to you on Twitter in 6 months. I'll be like, hey, I want penalized regression. Yeah, it's Twitter-based development. So you did sort of decry Docker containers, but there's a question about, do you have any pre-baked Docker containers with the volumes already ready to like persist the data to disk? Because some people, it's not for dependencies, they just don't want to install anything.
We don't have pre-built Docker containers. Yeah, I mean, I recently tried using Docker on my Mac, and it ended up using QEMU because of the M1 thing. And I think it was just it's just if you're running a data analysis through QEMU, then this is gonna be abysmally slow. Anyways, now I'm not opposed to creating Docker containers, but what you suggested a use case that was pre-built for what?
Basically, so like let's say you're using a database and Docker container, like Postgres even. You don't want the data living in the Docker container. You want a volume mapped to disk somewhere. So right. You have like a pre-built Docker image and a Docker compose that goes with it that makes the volumes for you. Okay,
but you can also just use DuckDB and directly use the file on disk.
Assuming that you can install DuckDB.
Which is
not. That's right. You can do that.
Which is not difficult. so right. we have like pre-built binaries. You can download those. You can just download the R package Python package. Pip install DuckDB will get you DuckDB. I mean, it's a 10 megabyte download or something like that.
Yeah, the Docker container would be far bigger, I'm sure.
Yes.
All right.
Then, no dependencies. Yay.
That makes a difference.
Yeah.
And then speaking of large data, there was a question about someone who has a very large SQLite file that they built up by just appending to it. They want to know, can they import that into DuckDB and I guess get rid of SQLite, or maybe not get rid of it, but they want to be able to import it.
Yeah, that's a great question. And I have been secretly in the background preparing something because I saw the question. So we are going to release something soon that's called the SQLite scanner. And the way this works is it's going to be an extension to DuckDB. And you can kind of, oh yeah, I've just loaded already. And what it does, it allows you to read SQLite files as if they were DuckDB tables. So what I can do here is I can, okay, I've already done this, but you can basically say SQLite attach and then point to a name of a SQLite file. And what this will do is will expose all the tables that are in this SQLite file as DuckDB tables. So for example, this here in this sakila.db, it's a standard test file for SQLite. I have a table called film. So I can just use that and query it, and you can see, okay, this looks a bit stupid. Okay, I don't know. I can just query this this film database as if it were a normal DuckDB table. But if you look at the query plan here, you will see that at the bottom of this query plan, there is no DuckDB table, but there is the SQLite file that contains this table. And the cool thing is we can do this 10 times faster than SQLite itself can read this file because we parallelize the scan of the SQLite file while using their own infrastructure. So that's something that we're gonna release super soon. It's just that we haven't gotten around to it yet.
Okay, then follow-up question to that. Let's say you have a bunch of data in CSVs or Parquet.
Yeah.
Is the mission to use DuckDB to process those CSVs and Parquets, or is it better to import those CSVs and Parquets into a DuckDB storage and then process it?
Yeah, it's a great question. And I think the answer is going to be it depends. If you have a read-only workload and your data is stored in Parquet files, we have a very competitive Parquet reader, which is able to read those Parquet files very quickly. And since you're only reading them, you probably don't gain a lot from putting it into DuckDB native storage, right? Now with a CSV file, it's a bit different. With a CSV file, you gain a lot by importing this into DuckDB because it becomes smaller. We have compression built in. And of course, it becomes much faster to read the CSV file the next time you want to read it. So there you gain. You also, of course, would want to import this into DuckDB storage if you're trying to do any kind of updates on this, right? If you're trying to modify this, like you have maybe you want to load this and then re-encode some of the columns, or you want to drop some data that looks funky, and then you really want to use this, be able to use transactional updates on this, and then you would import. But in general, yeah, so that's for CSV. I think it's clear that you would want to do this because of performance, and overall you would want to do this in case you have updates, you expect changes to the data, which of course you cannot change a Parquet file on disk. Of course, we can also write to new Parquet files, but I'm really trying to get people to stop re-implementing their own transaction mechanism based on flat files. This is really it's really bad. Yeah.
Cool. And you mentioned for windowing functions, writing custom functions. But let's actually talk about dplyr. You write your own custom function you want to use in a mutate or in a summarize. Can they call that in data in DuckDB?
That's actually something I'm working on right now. And that's gonna come to DuckDB. With the custom functions, which is we're gonna solve this through something we call user-defined functions, and we have also done this in the past. Demoed this. I think maybe we've also demoed it. No, I've demoed it as user in. Good question. Where was that? I think was that in Spain? Anyways, basically the we can automatically create user-defined functions from R in DuckDB using, and then call those during query processing from DuckDB. Again, we can call your functions. The only restriction is there that doesn't work really well with parallelism, because R doesn't allow you to parallelize and to run functions at the same time, much like Python.
Yeah, everyone talks about R is not parallel, so it's the same with Python the same way.
But a way around that, we're thinking about that actually with this particular topic, a way we're thinking to fix this, and this is going to be something we're going to build probably also for Python, is to have to basically be able to fork off additional processes that we stream the data through that runs in the query in order so we can parallelize. So that then we would be able to do that. But forking has its own, let's say, problems, especially when you're forking a process with potentially gigabytes of memory attached to it. That's problematic. That's even more problematic on Windows, and so I'm not entirely sure about the mechanics of that. But we have done some prototyping on this, and we will start with UDFs. And I think what we also want to do is to allow you, I mentioned this before for the window functions, that you want to be able to do scalar UDFs where you just value in, value out, but you also want to have something where you use R functions to compute an aggregate, for example, and that's a bit more involved, but we'll have to deal with that.
And I do see that Richard wrote that if you want to write C++, which I don't, you can write for that.
Yes, you can write UDFs in C++. That's right. You can also, I think we have some basic Python support for UDFs, but
okay. And then a question, actually, Jeff asked a question I was going to ask. Can you control parallelism? Because like if you're calling this as part of a parallel process, you don't want it using up all the cores. So how do you control parallelism?
Sorry about that. Yeah, you can. There's a pragma. You can say pragma threads equals to 4, and then it will use 4 threads.
And when you say pragma, is that like as part of your SQL query? Is that
is a SQL query? Yeah.
And you're calling queries from R. Actually, could you show it? Oh, there it is.
Yeah. So you would just be like, come from R. It would be db execute con something like that.
Okay.
And then it uses 4 threads, or as many as you want. By default, we use all threads, I think.
That's what it is. It's sort of like data table. Like data table uses all threads, but it can tell that if you're calling that within a parallel context, it reverts down to 1 thread.
Oh, interesting. No, I mean, it tends to be a good default to use all threads because it's quite rare that like this is the default. That's what you want. You want your default to be fast, right?
We had a talk from Henrik, I think Bergstrom, I hope I get his last name right, Henrik. He was like, writes the future package. He's like, the best default is 1 thread. This way you don't screw up people's computers and other people using it.
Henrik, yeah, I know. Yeah, I actually know him. Yes, I'm sorry about that, but it does matter. If your default is 1, then everybody's going to use 1, and only like the diehards are going to set this to anything more. Yep. And they're going to complain to us on our GitHub that it's slow. And then we'll have, this is a documentation problem. I like a training problem in that sense.
I hope Henrik's watching so you two can duke it out on Twitter.
No, I mean, I'll watch. He's a very nice guy.
No, that's why it's going to be a fun.
I wouldn't want to duke anything out with him. Fair. I think I was in the room when he showed the future package for the first time. It was fun.
Oh, that's awesome. You're in a lot of the good rooms at the right time.
And just the R community is so friendly, This is why I tend to hang out at their events. The database community is very unfriendly in comparison. This is really something that has opened my eyes in terms of how conferences should be run, for example.
Come to MYR, you'll see the friendliest conference you'll ever see. Yeah, and we pride ourselves on our food too.
Yes, that is a thing. That's not a thing in Holland.
We serve ice cream, sandwiches, and pizza and beer for our conference.
Oh, beer is a good idea.
We do have another question, not about food. Have you compared or benchmarked against TileDB?
No, but I'm not particularly impressed with TileDB. So, yeah.
Let's hope Dirk's not watching now. Yeah, but honest opinions. You are, I know you could all talk friendly. Cool. All right. That's all the questions I compiled. Well, I was going to grill you about GPUs, but you did say that it's fast enough already. So, I'll let that go.
Yeah, sorry. I mean, I think it's definitely, there's this thing that people try. I mean, okay, that just for the people without context, I think GPUs and SQL queries don't go that well together because the processing overhead that you do in a well-designed system per value, for example, is quite low compared to what GPUs generally are good at. So you lose a lot of thyou for a very questionable gains when you move SQL to GPUs, right? For example, you have very little memory. You go from 64 gigabytes of memory to 4, and suddenly you have to do all these crazy things in order to make the dataset fit. You have it takes time to move data there and so on. But it's also just a huge nightmare for engineering. You like writing SQL systems is hard, writing GPU systems is harder, and yeah. So it's so with if you don't need to, why would you? But what I wanted to say is it's cool, So you can get investors very excited about that, and you can also get nerds very excited about that. So it's something that to me seems like is done mostly because it's cool and looks great, but I haven't yet seen a GPU database benchmark that has convinced me, let's say, that this is feasible or a great idea in general.
Fair enough. It's like, I know that I've been excited about because I'm looking for faster queries. And I looked at, PG Strom, I think it's out of Japan. It's Postgres on a database on GPU.
Ouch.
What?
Ouch.
Yeah, and their queries show it's fast, but it's hard to install because,
Oh.
Yep.
Oh, that's also a problem because you have to deal with all this driver nonsense.
Yes.
That's not fun, and we want people to be able to use DuckDB wherever, So it's.
And I'm just going to throw in one more thing about it. I know the Voltron folks is made up of an NVIDIA guy. His name's escaping right now, but they're talking about Arrow on. That's actually that's how PG Strom works, and I think some of the CUDF it uses Arrow.
Yeah.
So now that you have the Voltron folks there, I'm just gonna push that there. I'm gonna text Wes and be like, hey, get Hannes to work on this just for fun.
Well, we talk to them regularly. So that's I know they are working on the CUDF thing. I think it's depending on what you do. If you do ML or if you do any kind of more like if you do anything that is more complex than running a SQL query, I think it makes loads of sense.
Yeah.
But not for what we do.
I get it. That's fair. Very fair. All right, cool. So I'm going to give everyone else just one last chance. Oftentimes when I say, okay, we're all done, someone sneaks in one more question. That's the way the world works. So
makes sense.
I will just go over some closing announcements. And if a question comes in, we'll happily turn this over. First, before I do any closing, another round of just little emoji or golf claps for Hannes. That was an excellent talk. I really, really enjoyed that. I do want to say thank you, Hannes, for responding to me on Twitter and agreeing to do this. I think this is awesome. Hopefully one day we'll get to have you here in person. Bring over to New York and you'll come give a talk again or just come enjoy someone else's talk. Coming up again next month, Bill Gold will be talking about the Brooklyn Bridge and how it relates to data science, amongst other things. But I think the Brooklyn Bridge is really, that really is a good hook. We have David Robinson in April. We have the New York R Conference in June 8th through 10th. There are workshops and conferences. We will be putting on a Stan workshop sometime this summer with Jonah Gabry, Rob Trangucci, Andrew Gelman, some other people from the Stan team. So we're very excited about that. We do that every summer, and we'll just figure out when we're doing it this summer. If anyone actually wants to have other workshops that we put on as part of the community, we put on workshops that we bring in an open source developer and we charge a fee that essentially funds the open source development. Let us know. We'll find the open source developer. Maybe Hannes will give a whole workshop. You never know. That's really how it happens. Some people give me an idea what they want, and then I go say, hey, go talk, and I arrange it. So we have that. Remember, always visit nyhackr.slack.com. We have this nice meetup community going. Also, if you want to see videos, nyhackr.org has 12 to 13 years of slideshows and videos that you can go and just click on the presentations tab and search for a topic or a speaker, and you can see so much cool stuff. Likewise, rstats.ai has a whole about 7 years worth of videos now from 2 different conferences. We also have our government focused conference. So it's really about like 10 different conferences worth of videos. So check out that. Lots of content out there available for you to enjoy. I did see there was a question, and I just want to make sure that Hannes gets answered out loud. Are there plans for foreign keys in DuckDB? And they've loved using DuckDB, but are there going to be foreign keys?
Yeah, we're gonna support those. There's currently a PR. Somebody else actually did that amazingly, but yeah, this is gonna happen mainly because people like foreign keys, and we are of course database populists, so we do what the people want.
Oh, then since you're working with Kirill closely, you could probably use the DM package to make.
Kirill is we work a lot with Kirill as well, I'm told DM works fine. So, but I haven't used it myself.
Kirill gave one of the last in-person talks, I believe, January, February 2020. Let's go to nyhackr.org and search for Kirill, and he talked about the DM package. So folks,
Oh yeah, cool.
Yeah, we get people passing through New York City all the time. So we get all those people from all around the world. It's amazing.
Cool.
All right. So that was like our sneak in question, I think. All right, everyone, go to nyhackr.org to see more. And just one more round of applause for our great speaker. And everyone should go enjoy their night, their day, or whatever it is. And we let Hannes go back to sleep, as it is.
Thank you so much. Hey.
So thank you very much, everyone. And we'll see you virtually and in person, virtually next month, in person, hopefully soon after that. Bye, everybody.